morning. So we're going to work on proving quadrilaterals on the quadriplane, on the coordinate plane. So how do I prove different types of quadrilaterals on the coordinate plane? So you guessed it. Yep, we're going to graph it. Okay, but we're going to go over our what they mean first. So quadrilateral. So remember, quad is 4. So like if somebody has quadruplets, so they have 4. Okay, so it's closed. So for all polygons, they're closed, 4-sided figures. So with polygons, that just means the sides have to be straight. Okay, 4-sided, straight. So the sides have to be straight, bigger. So that's a polygon. And parallelogram, the opposite sides. So we actually have 5 properties for parallelograms. So we have that the opposite sides are parallel. Okay. So opposite sides are parallel. And the opposite angles are congruent. Okay. And then a rectangle. Okay, so rhombus is a parallelogram with 4 congruent sides. So 4 congruent sides is a rhombus. Okay. So it's 4 congruent sides. Okay. Rectangle. All 4 angles are right angles, so they equal 90 degrees. The opposite sides are congruent and parallel, just like a parallelogram. Okay. So same for this one. So rhombus, also the opposite sides. Okay, so these opposite sides are also parallel. Okay, for a square, so a square is our regular polygon. So 4 right angles, 4 congruent sides, and the opposite sides are parallel. Okay, so opposite sides are also parallel. Okay, so it has 4 right angles and 4 congruent sides. Okay, so all of these, so parallelogram, rhombus, rectangle, and a kite, all of these are parallelograms, all of them. Okay, so for this one, so kite, okay, so kite has to compare, the consecutive sides are congruent for a kite. So 2 pairs of consecutive sides, consecutive congruent sides. Okay, and a kite is a quadrilateral, and a trapezoid has 1 pair. Okay, so 1 pair of parallel sides. Isosceles trapezoid is one where it has the non-parallel sides are congruent, still has 1 pair of parallel sides. Okay, so the non-parallel sides are congruent. Okay, and all of these, okay, so all of these shapes are quadrilaterals because they all have 4 sides. and the interior angle is equal 360. Okay, so to figure out if it has congruent sides, so remember you'll see like the little mark on it, right? Like if it's a square, okay, you'll see that mark showing that it's congruent. Okay, so the tick marks. Okay, we can use distance formula. Remember, another form of our distance formula is our Pythagorean theorem. Okay, so remember that's this one. So the change in change in x squared minus the change in y squared on the square root, like I said, or you can use Pythagorean theorem. It's another form of the distance formula, okay? And we can also use the definition of congruent, or congruency, but definition of congruent. Okay, parallel sides, so you'll see those arrows, okay, like we do up here. See, we have the arrows. Okay, so we can use our slope formula. Okay, so you can use the change in y over the change in x, or remember you can also use rise over run. They're going to have the same slope. Can also use definition of parallel lines. Or sides. Right angles. Okay, remember that's the one where you'll see the box symbol. Okay, so it looks like this. It'll have our little box. And slope formula. So you can show that they're perpendicular. Okay, so negative reciprocals. So like if we had negative 3/5, a reciprocal of that opposite reciprocal would be 5/3. Okay, so opposite reciprocal, perpendicular. Okay, really good on that one. Okay, so perpendicular lines. So if the lines are perpendicular, or perpendicular sides, and they also have to be right angles. Because every day we're angling. All right, so we're going to continue on. So now we're starting into the proofs part. Okay, these ones say prove or disprove. So they don't actually give us a given but they do want us to prove that it's a parallelogram. So I know this one's going to be my last statement. Okay. Well, last statement. So I am still going to graph it. So I'm going to have to go over 1, 2, 3, 4, 5, up 1, 2, 3. Okay, and then B is going to be 1, 2, 3, 4. And then 1, 0 for C. And then 1, 2, 3 for D. Definitely looks like a parallelogram. Okay, so we're going to do our statements and our reasons. Okay, so what we're going to have to do is we're going to have to prove that they are parallel. Okay, so we're going to have to prove that they're parallel. So I'm going to use rise over run. So right here. Okay, these slopes are going down, so they're going to be negative. So we're doing over 1, up 3, over 1, 2, 3, up 1. Okay, so that means the slope I'll write it down here. So the slope of AB and the slope of DC are both going to be equal to 3. Remember, it's rise over run over 1. So they both have a slope of -3. And then for A and D, parallel lines, everybody. It's not parallel, sorry, horizontal lines. Everybody, if you think about it, if you're on a flat surface, horizontal lines, sides, okay, the slope is always 0. If it's vertical, it's going to be undefined, but right now, so AD, so the slope of AD and the slope of BC is 0 because they are both horizontal lines. Okay, so they have the same slope. Okay, so that means, so I'm going to write that over here. So the slope of AB is equal to the slope of DC, which is equal to -3. The slope of AD is equal to the slope of BC. I'm thinking ahead. Okay, and that's, both of those are due to our slope formula. Okay, so the reason for that is our slope formula. So yes, rise and run does include in that. Okay, so that means, so since their slopes are the same, that means that those sides are parallel. So side AB is parallel to side DC, and AD is parallel to the side BC. Okay, so that's by our definition of parallel lines. So that means ABCD is a parallelogram. By our definition of a parallelogram. Parallelogram, opposite sides are going to be parallel. So you see this? So we proved the opposite sides were parallel, so it is a parallelogram. Okay, everybody, we got this. Okay, so we're going to continue on. So we'll keep doing these. Okay, so we're going to go ahead and graph it. So 0, 1, 2, 3, 4, -2. And then 0, 1, 2, 3, 4. Okay, so they want us to prove that this is a rhombus. Okay, so for a rhombus, so we have to first prove that it's a parallelogram. Okay, so we have to do that first, everybody. So we're going to do that first. So we'll do that just like we did with the last one. So notice this, there is a pattern to this. We're going to have to prove that the slopes are the same. So we're going to have to go over 1, 2, 3, 4, over 1, 2. Okay, so for our slopes, sorry, over 1, up 2. Okay, same with this one, over 1, up 2. So 2 over 2, up 4. Okay, so I'm just looking at these. Okay, and these slopes, so we have these slopes right here. Okay, so the slope of AB and the slope of DC. Okay, so remember it's rise over 1, so -4 over 2, which simplifies to -2. Okay, and then I can do my other slope. So now I can do my other slope from this one. So now we have, it's going to be so 2, 4. over 2 down 4. Okay, and this is a positive slope. So the slope of BC, well, those are going uphill. Okay, so the slope okay, so negative 2 over negative 2. So that's how it would become positive. So for these ones, so the slope is going to be, so we have BC and AD. So we're going to have over and down 4. So that's going to be negative 4 because we're going down 4. So it's going to be negative 2. Okay, so we proved that the slopes are the same, so we can put that over here. So since we proved that the slopes are the same, everybody, remember that means that those opposite sides are parallel. That's why we do this. Okay, so just remember to keep looking at it. If it's going up, the slope is going to be positive. Going down, it's going to be negative. Okay, so this is our slope formula. And we know that they're parallel by our definition of parallel lines. If they have the same slope, then they are parallel. I think of it like train tracks, everybody. Think of it like train tracks. Okay, so that means that it is a parallelogram. So ABCD is a parallelogram. And that's by our definition of parallel lines, definition of parallelogram. So parallelogram, the opposite sides are parallel. Okay, so now we can use the distance formula to find the lengths. Okay, so for this, so for all of them, notice that it's all 4 by 2. So we're going to use the distance formula. So remember, or we can also use Pythagorean theorem. And that's what I'm going to use. So notice all of them are 4 by 2. So we're going to do 4 squared plus 2 squared is equal to c squared. And then we're going to take the square root of each side. And we're going to get square root of 20. 16 plus 4 is 20, which is approximately 4.47. So we round that up to 4.5. Okay, so that means for all of these sides, so side AB, CD, AD, and BC are all equal to 4 5/10. Okay, and this is by our distance formula. If they're all congruent, then that means if they're all the same measure, that means that they're all congruent. So side ABC, so side AB is congruent to CD, is congruent to AD, is congruent to BC. Okay, and so that would be by our definition of congruent. All the same measure, everybody. Remember, that means that they're all the same. Okay, so then that means that ABCD is a rhombus. So ABCD is a rhombus. Okay, so on this one, so we're gonna go ahead and do this. So we're gonna go over 1, up 1, 2, 3, over -2, up 1, 2, over 1, down 1, 2, over 1, 2, 3, down 1. Okay, so this one, they want us to prove that it's a rectangle. Okay, so they want us to prove that. So we're going to do our statement and our reasons. Okay, so our first step, everybody, is we're going to do slope. So we have to prove that that it's a parallelogram first. Okay, so we're going to have to prove it. So these are going up. So I'm actually going to start with these sides. So up 1, over 1, 2, over 2, up 1. Okay, so these are both going up. So the slope of BA is equal to the slope of CD. Okay, everybody remember again, rise over run. For slope. Okay, so rise. So we go up. Rise, I think we always go up. And run, we always go over. Okay, so it's going to be up 1, over 2. So our slopes are 1/2. And then for our next one, so let's do the other one. So these are going downhill. Okay, so that means that it's going to be 1, 2, 3, 4, down 4, over 2, over 2, down 4. Okay, so notice we're going down. So the slope of BC is equal to the slope of AD. So it's going to be -2, -4 because we're going down 4 over 2. So it's going to be -2. Okay, so we got our slopes. So the slope of BC is equal to the slope of AD, which is -2. You are going to need to know how to do this. So the slope of BA is equal to the slope of CD is 1/2. And everybody, I'm doing the rise over run, but of course everybody can also use the change in y over change in x formula for slope too, whichever one you want. Just graph it. So since the slopes are opposite sides have the same slope, that means that they're parallel. So I'm just marking on here. Okay, so AB is parallel to CD. Okay, and so that also means that BC is parallel to AD. Okay, and that's our definition of parallel lines. So that means that ABCD is a parallelogram. So that means so it's a parallelogram by our definition of parallelograms. Remember parallelograms, opposite sides are parallel. It's one of our 5 properties. Okay, and then we're going to go to the next part. So our next part, we need to prove that that it's a rectangle. So we have to prove that they're perpendicular. Okay. We know that they are because if you look at the slope. So if I remember I said for perpendicular lines, okay, so for perpendicular sides is what we're talking about right now. When I multiply those two slopes together, okay, so I'm going to multiply the slope of BA times the slope of BC. It should equal -1. And I checked that, and it does work. So if I multiply 1/2, I should actually make this AB, sorry. So 1/2 times -1. Remember, whole numbers over 1, it does equal -1. Okay, so that means that they are perpendicular. Okay, so that means that AB is perpendicular to BC. AB is also perpendicular to AD. CD is perpendicular to BC. CD is perpendicular to AD. Okay, and that, so all of this is our definition of perpendicular lines or sides. Okay, so that means that angle A, angle B, angle C, and angle D are right angles. Okay, and that's definition of perpendicular. So remember, it's going to form right angles, like university and country club. So streets. So ABCD is a rectangle. And that's by definition of a rectangle. Okay, we're done with the proof. Whew. Okay, so this one, again, prove or disprove that it's a square. Okay, so of course we're going to graph it, everybody. So 1, 1, 2. 0, -1. Okay, so we got this, everybody. So of course we need to prove that the slopes are parallel. So the slope of AB is equal to the slope of CD. Okay. You can definitely use, like I said, everybody, it's totally up to you. I'm using rise over run, so 1 over 2, 2 over 1. Okay, so, and it is, so it's over 2 up 1, so it's going to be positive. Rise over run, so 1 over 2. Okay, the next one, we're doing the same thing. So for the sides BC and side AD, okay, so it's going down 2 over 1, so down 2, so that means it's going to be negative, okay? So -2. Okay, so we're going to go ahead and prove it. So that proves our slopes. So since the slopes are congruent, that means opposite sides are congruent. So slope of AB is equal to slope of CD. So that's 1/2. Slope of BC is equal to slope of AD, which is -2. Okay, so those are both by our slope formula. That would be our reason. Okay, that means that that they're also parallel. So AB is parallel to CD. So I can mark that on here. And BC is parallel to AD. Okay, and that's by our definition of parallel. Okay, so that means that it is a parallelogram. So ABCD is a parallelogram. And that's our definition of parallelogram. So definition of a parallelogram. Okay, so we need to prove, okay, so we need to make sure. So when we multiply those slopes together, so -1/2 times -2 does equal -1. Okay, so that means that they are perpendicular. So that means that AB is perpendicular to BC. AB is perpendicular to AD. CD is perpendicular to BC. CD is perpendicular to AD. Okay, so this is definition of perpendicular. And that also means that since they're perpendicular, the angles ABCD are right angles. So angles ABCD are right angles. Okay, and that's definition of perpendicular. Okay, so we need to prove that it's a square, so it means we need to prove that the sides are congruent. So we know that all the sides are 2 by 1, so I can use I'm going to use Pythagorean theorem. Okay, so we're going to go 2 squared plus 1 squared is equal to c squared. Take the square root of each side. So we're going to get square root of 5. 4 plus 1 is 5. Okay, which is approximately 2 2/10. So all the sides, so side AB, CD, BC, and AD are all equal to 2 2/10. Okay, and that's by our distance formula. Remember, Pythagorean theorem is another form of the distance formula, which means that they're also, since the measures are congruent, are the same. Since the measures are the same, everybody, it means that they are congruent. So all the sides are congruent. So definition of congruent. Okay, since it is a parallelogram and all the angles are right angles on this, I feel like I can just add more stuff. That means that it is a square, so ABCD is a square. Definition of a square. We got this. Okay, last one, everybody. Okay, so we're going to prove or disprove that it's a rectangle. Okay, so I'm actually going to skip that one. I think everybody, you've gotten enough of this. So you got this. No, you are going to need to do the distance and the slope formula. You got this.